In this video, I'm going to solve question 5 from November 2022 from DBE. Okay, so the question is on function grade 12. Okay, we are going to deal with inverse functions and linear functions. Okay, so this is the question. It's question 5 from November 2022 from DBE. You can see you have 5 questions to solve from 5.1 to 5.5. The total is 13 marks. Okay, you can see that. Let's get started on the next slide. Okay, we start with question 5. Okay, let me get the question. Question 5 from November 2022. Okay, this is the question. So let me read the question. Question 5, the graphs of g of x is equal to 2x plus 6 and the inverse of g are shown in the diagram below. Okay, D and B are the x and y-intercept respectively of g. C is the x-intercept of the inverse of g, and the graphs of g and the inverse of g intersect at A. Okay, so this is the graph of g, and this is the graph of the inverse of g. You can see D is the x-intercept of g, and B is the y-intercept of g. C is the x-intercept of the inverse of g. Okay, there's C, the x-intercept of the inverse of g. The graphs of g and the inverse of g intersect at A. Okay, there's the point A, the point of intersection of the graph of g and the inverse of g. Okay, so they intersect at the point A. Now question 5.1. 5.1, the question is write down the y coordinate of B. The question is 1 mark. Okay, write down the y coordinate of B. There is the point B. You can see you have the point B there. So you need to write down the y coordinate of B. Okay, the point B lies on the graph of G. You can see the equation of G is 2x plus 6. So it is given in the form mx plus c. Okay, mx plus c. So this is a linear function. So the value of c is 6. So from this value, you know that the y-intercept is 6. Okay, so this is the y-intercept. You can see it is on the y-axis. So the y-coordinate of B is 6, and the x-coordinate of B is 0. Remember, at the y-intercept, x is equal to 0. So the y-coordinate is 6. Okay, so the y-coordinate of B is equal to 6. Now the next question, 5.2, the question is determine the equation of the inverse of g, right? Determine the equation of the inverse of g in this form. Okay, the inverse of g is equal to mx plus n. Okay, the question is 2 marks. Okay, you need to determine the inverse of g, right? So you need to determine the equation of this line. You have to determine it in the form mx plus n. Okay, so you are given g of x is equal to 2x plus 6. Okay, you can see that g of x is equal to 2x plus 6. Now the question is to determine the inverse of g. Okay, let's change first this to y. This is y, right? So this is y is equal to 2x plus 6. Okay, now from this, you have to exchange your x and y. Okay, this is what you do whenever you want to get the inverse of a function, the inverse of an equation. You exchange your x and y. Okay, I have y there. I'm going to have x is equal to 2y plus 6. Okay, you exchange your x and y. Wherever you have x, you put y, and wherever you have y, you put x. Okay, this is what you do. Now, you need to make y the subject of the formula. Okay, before you can do that, you can take 2y to the left. It becomes negative 2y, right? 2y to the left, it becomes negative 2y. This is equal to, you take x to the right, it becomes negative x. Okay, x to the right, negative x, and 2y to the left, it's negative 2y. Okay, and then plus 6. Okay, I hope you can follow. Now you need to get y on its own. You need to get y the subject of the formula. What you can do is to divide by negative 2 throughout. Okay, so I'm going to divide by -2 so that I can get y on its own. Okay, you divide by -2 throughout. Okay, remember that. By -2 and this by -2. Okay, now this and this are going to cancel. You only have y is equal to, you have negative divided by negative, this is positive, right? And then you have 1, there is an invisible 1 there, 1 over 2, right? 1 over 2x, okay? Negative divided by negative is positive. And we have 1 over 2x, okay? You carry on. Now you have positive divided by negative, it's negative. 6 divided by 2, it's 3. Okay, so this is the equation of the inverse of g. Okay, now the question is asking you to write in this form. Okay, you can just change this y to this. Okay, you have found the answer. Just change the y to this. Okay, so the y is going to be this and this. This is what you have there, right? You didn't change anything. You only change your y to this because the question is asking you to get the answer in this form. Okay, so this is the final answer. Now 5.3, the question is determine the coordinate of A. Okay, this question is how many marks? 3 marks. Okay, 3 marks. When you look at the graphs, you can see that A is the point of intersection. You can see A is the point of intersection of the graph of G and the inverse of G. Okay, so what you are going to do is to take the equation of G, you equate it to the equation of the inverse of G. Okay, this is what you do whenever you are trying to get the coordinate of the point of intersection. Okay, you take the equation of G, you equate it to the equation of the inverse of G. Okay, this is what you do. So the equation of G, you have it there. G of x is equal to 2x plus 6. And the equation of the inverse of G, of this line, you have it. You calculated it. Okay, so it is equal to this, right? You can see that. Now you have the equation of this line and the equation of this line. So you have 2x plus 6 is equal to this, right? Remember, this is your y and this is your y. Okay, this is y and this is y. You can take this, you equate it to this so that you can find the coordinate of the point of intersection. Okay, now you carry on. You have 2x and you have 1 over 2x, right? 2x, 1 over 2x. These are like terms. Okay, you can take 1 over 2x to the left. Now you have 2 minus a half, right? 2 minus a half. These are like terms. Okay, 2 minus a half. This is going to give you 1.5. Okay, 2 minus a half is 1.5. So 1.5 can be written down as 3 over 2. Okay, 3 over 2. Okay, this is 1.5. When you take 2 minus a half, it's 1.5. And you can write it as a fraction. Okay, remember x because these are like terms. Okay, this is equal to, you only keep x on one side. Now you can take the 6 to the right. Now you have -3, -6, right? -3, -6. This is -9. Okay, so now you need to solve for x. Okay, so what is x equal to? You are going to multiply by 2 over 3 so that the 3 and the 3 can cancel and the 2 and the 2 can cancel. Okay, let me say that again. You are going to multiply by 2 over 3 so that you can have cancellation. Okay, remember what you do on the left, you also do it on the right. Okay, so when you multiply by 2 over 3, you are going to have x is equal to, you do the same on the right. Okay, let me use a calculator so that you can see what I'm talking about. Okay, so when you have the calculator, so this is the calculator. Okay, after multiplying by 2 over 3 on the left, you also multiply the right side by 2 over 3. Okay, you have -9, right? You multiply by 2 over 3, the same number as you multiply on the left, you also use it on the right. Okay, 2 over 3 times -9, and this is equal to -6. Okay, I hope you can see that. Okay, x is equal to -6. Okay, now this is the x coordinate of the point A. You need the y coordinate of the point A. Okay, you have the x coordinate of the point A. You need the y coordinate of the point A. Okay, you are going to take this value, you plug in there or in there, right? You can plug in this equation or in this equation because they have a common point. They have the same x and the same y value at that point. Okay, this is why you can plug this value inside this equation or inside this equation. Any of the equation, you are going to get the same answer, the same value, the same y coordinate. Okay, let me use this. So I'm going to take g of negative 6, right? G of negative 6 is equal to, I have 2 times x. X is negative 6. Okay, you plug negative 6 wherever you see x. Okay, you plug negative 6 wherever you see x. So you have 2 times negative 6 and then plus 6. Okay, and this is negative 12 plus 6. So you have 6 minus 12. This is equal to negative 6. Okay, so you can see the y coordinate is negative 6. You can still use this equation. You are going to find negative 6. Okay, so finally, the coordinate of A are negative 6 and the y coordinate is also negative 6. Okay, so this is how you can calculate the coordinate of the point of intersection between two graphs. Okay, let's carry on. Now the next question, let me draw a line here, right? Okay, now it's 5.4. The question is, calculate the length of AB. Okay, this question is 2 marks. Okay, calculate the length AB, right? There's A and B. Okay, AB. You need to calculate this length. Okay, in this question, you can use the distance formula. Okay, this one, AB is equal to this. Okay, you can use the distance formula. Okay, we are going to cover this in analytical geometry. Okay, so you can use this formula to get the length AB. Okay, so you have the x coordinate of A minus the x coordinate of B in bracket square plus you have the y coordinate of A minus the y coordinate of B in bracket square and you have the square root. Okay, you can see that. Okay, so let's use this formula to calculate the length AB. Okay, you have the coordinate of A. Okay, you can see the coordinate of A, right? These are the coordinate of A. You also need the coordinate of B, right? What are the coordinate of B? You can see there's B. It is the y-intercept of the graph of G. Okay, you have the y coordinate. It's 6. So at the y-intercept, x is equal to 0, right? So the coordinate of B are 0 and 6, right? This is the y coordinate. It's 6. And at the y-intercept, x is equal to 0. Okay, so these are the coordinate of B. You can see that from there. You can see from the equation, you can see that the coordinate of B are these. Okay, now you have the coordinate of A and the coordinate of B. You can use these coordinates to calculate the length AB. Okay, so AB is equal to square root of, in bracket you have the x coordinate of A. There's A. The x coordinate is negative 6 minus the x coordinate of B. There's B. The x coordinate is 0. You close the bracket, square. Remember, the first coordinate is always x and the second coordinate is always y. Okay, the first coordinate is always x and the second coordinate is always y. Okay, let's carry on. Plus, you have the y coordinate of A. There's A. The y coordinate is negative 6 minus you have the y coordinate of B. There's B. The y coordinate is 6 square, right? We can carry on. AB is equal to, you can plug this in your calculator and get the answer. Let's do that. Okay, so this is my calculator. Let me plug this in the calculator and get the answer. So you have negative 6 minus 0 square plus negative 6 and negative 6 square. This is equal to 6 square root of 5. Okay, 6 square root of 5. Okay, so this is the length AB. You can write it as 6 square root of 5 units, right? Or this is equal to, if you can write it in decimal, okay? In decimal, it is 13.42. Okay, you can see that 13.42 in decimal. 13.42 units. Okay, so you can give the length like this or in decimal. Okay, so this is how you can calculate the length AB. Okay, use this formula. Okay, now let's carry on. Okay, question 5.5. The question is calculate the area of triangle ABC. Okay, calculate the area of triangle ABC. The question is 5 marks. Okay, calculate the area of triangle ABC. Let me get the question. You can see from the question, A, B, C, they form a triangle. Okay, A, B, C, they form a triangle. So the question is to get the area of this triangle. Okay, so let me get this drawing down here. Okay, so this is the drawing that you are given. You can see A, B, C, they form a triangle. Okay, I can close this. So you have A, B, C, and I can close there so that you can see the triangle. The triangle is A, B, C. Okay, so the area of a triangle is half times base times the perpendicular height. Okay, you can use this formula to get the area of this triangle, or you can use other methods to get the area of this triangle. Okay, in this video, I'm going to use this formula. Okay, so BC can be regarded as our base, and the perpendicular height will be from A to the middle of BC, in the middle of BC. Okay, from that point to the middle there. So this is our perpendicular height. Okay, so it's forming an angle of 90 degrees there because it is perpendicular. Okay, so you take the perpendicular height. So this line is perpendicular to this line. Okay, so this is our perpendicular height and this is the base. Okay, so you need to get the length of the base and the length of the perpendicular height. Okay, so BC is the base. Okay, BC is the base, and now you have this distance, which is the perpendicular height. Okay, from that point to that point, you have this is a perpendicular height. Okay, let's get the length BC. Okay, you have the coordinate of B. Remember from the question, from the previous question, the y coordinate of B is 6 and the x coordinate of B is 0. Okay, remember from the equation of G. So the coordinate of B are these. Okay, 0 and 6. This is the y coordinate. So the line G is cutting the y-axis at 6. Okay, you can see that from the equation of G. Okay, and remember at the y-intercept, x is equal to 0. Okay, you also need the coordinate of C so that you can calculate the base, this length BC. Okay, the coordinate of C, you can see G and the inverse of G, they are what? They are symmetric about the line y is equal to x. There is a line y is equal to x there. So since this is the inverse of G, these two graphs, they are symmetric about the line y is equal to x. Okay, if the line G is cutting the y-axis at 6, now the inverse of G is going to cut the x-axis at 6 because these two lines, they are what? They are inverse of each other and they are symmetric about the line y is equal to x. Okay, so the coordinate of C are going to be 6 and 0. Remember at the x-intercept, y is equal to 0, right? At the x-intercept, y is equal to 0. Now you have the coordinate of B and the coordinate of C. You can use these coordinates to calculate the length BC, which is the base. Okay, BC is the base. Let's get the length BC. You can use this formula, the distance formula, right? You have the x coordinate of B minus the x coordinate of C in bracket square plus the y-coordinate of B minus the y-coordinate of C in bracket square. So this is the distance formula. You can use it to get this length, which is the base. Okay, let's use it. So BC is equal to square root of, you have the x-coordinate of B, you have B there, the x-coordinate is 0, minus the x-coordinate of C, it's 6, square, plus the y-coordinate of B, it's 6, minus the y-coordinate of C, it's 0, right? This is x and this is y. This is x and this is y. The first coordinate is always x and the second coordinate is always y. Okay, so the y-coordinate of C is 0. Okay, you carry on. This is equal to, when you plug this in your calculator, you are going to get 6 square root of 2. Okay, you can check it with your calculator. So the base is 6 square root of 2. Okay, units. Okay, BC is equal to 6 square root of 2. Now you need the perpendicular distance. You need this distance. Okay, you need to get the length, this length, which is the perpendicular height. Okay, so that you can use this formula to get the area of this triangle ABC. Okay, to get the length of the perpendicular height, you can use Pythagoras theorem. Okay, using Pythagoras theorem, remember the Pythagoras theorem is used in a right-angled triangle. So you can use this portion of a triangle, only this portion. So this is a right triangle. You can see a right triangle has got an angle of 90 degrees. This is a 90 degrees angle. So you can use this portion using the Pythagoras theorem. You can get this perpendicular height. Okay, in a right triangle, this is what the theorem of Pythagoras theorem. In a right triangle or right-angled triangle, the square of the hypotenuse is equal to the sum of squares of the other two sides. Okay, in a right-angled triangle, the square of the hypotenuse is equal to the sum of squares of the other two sides. Okay, the hypotenuse is the side opposite to the right angle, or this is a 90-degree angle. So this side, which is opposite to this angle, is known as the hypotenuse. It is the longest side in a right triangle. Okay, this is the longest side. It is known as the hypotenuse, and it is the side opposite to the right angle. Okay, so let's use this theorem. So you have the square of the hypotenuse. The hypotenuse is AB, right? AB square is equal to this side, not BC, but from there to that point. So this is half the length BC, right? So you have BC half square, right? This is BC divided by 2 square plus, so you have this side square plus this side square is equal to the hypotenuse square. Okay, so you have this side, it's there, square, plus now you have this, which is what? The perpendicular height. Okay, let's write it like this, perpendicular height square. Okay, so this side square plus this side square is equal to the hypotenuse square. This is always the case whenever you are dealing with a right triangle. Okay, this side square plus this side square is equal to the hypotenuse square. Remember, the hypotenuse is the longest side in a right triangle. It is the side opposite to the 90 degrees angle. Okay, so this is the Pythagoras theorem. You can use it to get this. This is the perpendicular height. Okay, so let's use it. Now you know AB from the previous question. AB is equal to 6 square root of 5. You can check that from the previous question. You calculated for the length AB. AB is equal to 6 square root of 5 square. This is equal to BC over 2 square. You have BC there, right? So BC is 6 square root of 2 over 2, right? You only need this distance because you are dealing with this right triangle. Okay, so you need this distance. So you have BC over 2. This is BC over 2 square plus you have the perpendicular height square. So you have this, right? You take this to the left, it becomes minus this, right? This is equal to, you remain with only this. Okay? You can carry on. You are trying to get the perpendicular height. What you can do is to take the square root on the right and the square root on the left so that you can get rid of this square. Okay? You take the square root on the right and the square root on the left. Now you have this perpendicular height. When you take the square root, you have this perpendicular height is equal to what you have there. You can plug this in your calculator and then you are going to get the perpendicular height. Let's do that. Okay, I have this square root of, you have 6 square root of 5. Okay, square, right, minus, you write it the way it is. Okay, 6 square root of 2 over 2. Remember, you close your bracket and then square. Okay, this is what you have there. This is equal to 9 square root of 2. Okay, 9 square root of 2. I hope you can see that. Okay, so this is what the length of the perpendicular height. Okay, 9 square root of 2 units. Okay, now you have everything that you need to calculate the area of the triangle. Okay, the area of the triangle is equal to, remember the triangle ABC. Okay, you have half times the base. The base is BC. You have it there, right? 6 square root of 2. Okay, 6 square root of 2 is your base, BC. Okay, times the perpendicular height. Okay, the perpendicular height, you calculated it. It's 9 square root of 2. Okay, and this is equal to, plug this in your calculator. So you have half times 6 square root of 2, 6 square root of 2 times 9 square root of 2, right? You can see that. This is equal to 54, right? 54 units square. Okay, remember it is the area. 54 units square. Okay, so we are done with question 5 from November 2022 from DBE. Okay, until next time, I will talk to you soon.